Hello, welcome back to my channel. So till now, we have seen what happens when a user click a button and why system feels slow. But a bigger question is, what happens when a lot of users comes in, right? Like not just 10, not just 100, but say 1 million users or more. How does the system not just die eventually? So, to understand this, let's start with the simplest version of it. Let's get started. So let's start with the simplest version. I'll draw one simple basic app design. This is the user, this is the server. Let's suppose this is my database. So this I can name as my user. This would be my one server for now. And this is my database. So the user flow would be the users connects to the server, then the server connects with the database. Simple basic flow, right? Works perfectly fine when the traffic is low. But now, imagine 1 million users hitting this. What breaks? What actually goes wrong? Too many requests hits the server, CPU gets overload, or the database get hammers. Everything becomes slow, and eventually it just crashes. So the first instinct for you would be, instead of having the small server, let have some bigger server. So we'll increase the server, right? Have a bigger server in place. More RAM, better CPU, and yeah, it helps a bit, but only till a point because it's expensive. There's always a limit, and it's still just one machine. So this does not really solve the problem. So the better idea would be doing horizontal scaling. So in horizontal scaling, we don't have a bigger server. We have multiple servers in place of it. So server 1, server 2, and server 3. Instead of making one bigger server, we added more servers like server 1, server 2, server 3. Now the traffic is distributed. Sounds good, right? But wait, how does the request decide which server to go to? Now, to decide that, one more concept comes in into the system design picture: load balancer. So, the load balancer is responsible to distribute the traffic among the each server which are present in the environment. So it can traffic distribute the traffic amongst every server. In the further videos, we'll talk about more on the load balancer. But now notice something. All these servers still talks to the database, which is same. So now the database becomes the bottleneck. One fix can be using read replicas, right? So instead of having one single database, I can have main DB which covers my write operations. Then I can have multiple read databases as well instead of placing this. So I can have suppose three read databases. Assume these are my three read databases only, which controls my read operations. So writes goes to the main DB, read goes to the replicas, the three replicas which we created. Now read load is separated out. The fix too can be sharding. I can have like two databases. Some people do sharding based on reasons, some do it based on the users. So like for example, suppose based on the users, I can have in this database users till A to M alphabetically, and I can have the another database with users N to Z. I have two databases for different set of users. So multiple DBs handle different parts, right? Now, this is probably the most important one. We have cache between a server and database. Most requests are usually repeated. Same user data, same fate, same responses. So instead of hitting DB every time, we store it in a cache. If cache hit, super fast. If miss, go to the DB, store it back. This reduces a lot of load. Honestly, this is the main takeaway. Find, fix, and repeat. Scaling is not like add more servers and done. It's more like find the bottleneck. Where is the app getting slow? Fix it. Then the next bottleneck appears. Because you fixed one, this load will go somewhere else. Fix that and keep on going. Also, nothing is free, right? Performance increases, complexity also increases. Caching can give stale data sometimes, if not properly configured. Replicas can have consistency issues across the database. Sharding are more harder for queries. So every important improvement adds complexity. So our final pictures look like this. This is roughly how the real systems looks like. Not super complicated, but built step by step. So thank you for watching this video. If you do like the video, do subscribe the channel and let's see you in the next one.